put the laptop away. That'd be great. So, on Friday, one of the things that I focused in on in talking about is that rational functions have a lot of different appearances to them. Their different appearances come out of the fact that there's a lot of different ways to get those points of discontinuity, or in other words, holes and vertical asymptotes in them. Holes happen when you have a vertical asymptote, or when you have the denominator equal to 0, but it's a part that cancels out. While vertical asymptotes are the part that's left in the denominator equal to 0 that didn't cancel out. There are also horizontal asymptotes. To determine the horizontal asymptotes, you have to look at the degree of the polynomial. What's the degree again? It's power. It's exponent. It's biggest exponent specifically. If the degree of the numerator is bigger than that of the denominator, then there's no horizontal asymptote, but the possibility of an oblique asymptote. If the degrees are the same, you divide the leading coefficients, and that'll be your horizontal asymptote. If the degree of the top is smaller, then it has a horizontal asymptote at 0. Okay, last thing is that oblique asymptotes, they happen when the degree of the top is exactly one higher than that of the denominator, and you can find it by doing polynomial long division. Okay, so that's where we left off. We got a lot of information going into it, but today we're going to get to the actual graphing. So, as we go through this section, we are going to sketch the graph, meaning it doesn't need to be a perfect version of the graph, it just needs to have the important pieces in the accurate places, i.e. the asymptotes and the holes of the graph, and then the actual shape of the graph itself in the correct place. So, when it comes to these problems, general rule of thumb is to go through and look for the important parts that we need. The first thing that we are going to try to do as we go through this process is we are going to try to simplify the expression if possible. This is essentially what reveals any possible holes in the graph. In order to simplify, I must do what? Factor, if possible. Can I factor x cubed? No, monomials will not factor. Can I factor x plus 1? No. So, does not simplify. There are no holes in this graph. If it does simplify, if things start crossing off, that's when you're going to start getting holes in the graph. Okay, after you've tried to simplify, you've checked for any holes, the next thing you're going to look for is you're going to look for any vertical asymptotes. Vertical asymptotes can be found by setting the denominator, specifically with anything canceled out of it that you can, gone, equal to 0. And you solve that equation. How do I solve x plus 1 equals 0? Subtract 1 and x will be equal to -1. Next thing I look for, after I've done all of my vertical asymptotes, remember there can be multiple, I look for any horizontal asymptotes. Isn't I? So I'll look at my degrees. What is the degree of my numerator? 3. What is the degree of the denominator? 1. Now, if it's simplified, I often want to look at the simplified degree, but that can be hard to look at. We'll talk about if that happens, what to do. Okay, so my degrees are 3 and 1. Would you agree with me that 3 is bigger than 1? Yes, no, maybe? What does it mean if the degree of the numerator is bigger than that of the denominator? Here's where having this information is key. There is no horizontal asymptote. Last thing we check for is oblique. Now here's the thing. The only way you can have an oblique asymptote is if there's no horizontal asymptote. If there is horizontal asymptotes, oblique asymptotes do not occur. So there is no horizontal asymptote here, so I'm going to check for if there's oblique. The rule for oblique is that m is equal to n plus 1, where m and n are the degrees. Is 3 equal to 1 plus 1? I just plugged in my m and my n, my 3 and my 1 that I found earlier. Is 3 equal to 1 plus 1? No. That means there's no oblique asymptote on this one either. Once I've figured those things out, I can now go to actually looking at my graph. Now when it comes to drawing yourself an XY axis, the key thing that you want is you need to have room, specifically when it comes to the vertical axes, on every single side of the vertical axes. If there's one vertical asymptote. If there's one vertical asymptote, you need to have room to the left of it and to the right of it. If there's 2 vertical asymptotes, you need to have room to the left, to the right, and in between. Because the number of sections that your graph will show up in is always going to be 1 more than the number of asymptotes. Vertical asymptotes will always separate parts of the graph. So you need to have room to graph those. I have 1 vertical asymptote at x equals -1. So I go here, I'm going to call that -1, and I am going to put my vertical asymptote in. I have room to the left of it, I have room to the right of it. I make sure to label it on the graph, x equals -1. It's my only asymptote. From here, if I want to figure out what the graph looks like, it's a sketch. It doesn't need to be perfect. I have a graphing calculator for a reason. How do I get into my graphing menu on my graphing calculator? Depends upon your graphing calculator. If you have a TI, you just click the Y equals. If you have a Casio, yes, you click menu, and then you click the thing that says graph. Sorry, I just remembered that my Casio is dead. And while I have plenty of other Casios, the light up one is the one that shows up over the screen well. So, if I can find one that can turn on the batteries. Did you end up with a dead one? Oh, yours is dead? Yeah. Okay. So as we were. So TI, I click Y equals. Casio, I go to my main menu and I go to graph. Mine was already there. If it's on a graph, click exit. Anytime your Casio is on something you don't want, generally click exit a bunch of times. If it stops changing, then click the main menu and figure out which of these you ended up in and go back to what you're looking for. In this case, the third one, graph. Okay, now we type in our equation. In order to type in our equation correctly, we need to make sure that there's not going to be things on our calculator that are going to mess with us. For example, my TI calculators, do you see where it says stat plot 1, plot 2, plot 3? If those plots are turned on, your calculator is going to yell at you about your statistical dimensions. Are we doing stats right now? So those should be turned off. Here's how you know if they're off or on. Are they highlighted or not? Mine are currently not highlighted. If yours are, if they look like that, you need to get that turned off. So scroll up, click enter, and scroll back down, and it will turn it off. On the Casios, what often happens there is the type of graph that you're given gets changed. These better all be Y's. If they're X's, if they're R's, if they're T's, if it's a mixture of X's and Y's, you've got issues. There are different types of graphs that you can do on these calculators. The TI does it too. It's just harder to change on the TI, so it doesn't generally get accidentally changed on the TI. But the Casio gets changed all the time. We are looking for a general Y equal type of graph. I emphasized type for a reason. Any thoughts as to why I emphasized type to my Casio users? Look at the bottom of the screen. Do you see the word type? You got to know how to switch this stuff. I am not going to be helping everyone with all of their calculator missteps throughout the entire trimester. You got to get to know a calculator. So, if the wrong thing is popping up, click type. What type of equation do we want? We want Y equals. Okay, from here we start typing stuff into our calculator. Where is the X on the TIs? Because I need X cubed. Where's X? Where is X on the Casio? Below alpha. So it's either to the right of alpha or it's below alpha. X all of a sudden shows up on screen on the Casio, but those are not variables. So X, how do I put to the power of 3? The caret looking button, above the divide symbol on a TI, next to the squared button on a Casio. Far too many people only know where the squared button is. To the power of 3. Now, if you've got either a fancy Casio or you've got the TI-84, you need to get out of the exponent by clicking the right arrow. These generalized Casios will not have that issue. What is a fraction bar? Divide symbol. Divide. But make sure that when you're dividing by it, you're dividing by what? X plus 1. But I can't just put X plus 1. If I put this in, I've got issues. Do not forget to put parentheses around things with pluses and minuses. Once you have it in, click enter or execute on your calculator. It'll go down to Y2. That's what you want it to do. Everyone gotten as far as gotten their equation typed in? Now, if your calculator is set up with a standard viewing window, most of the time that's going to give you what you need. A standard viewing window you can get to by getting into your window button. You having issues? Okay. Your window will tell you, your viewing window, which on the TI is just this button, on your Casio, Shift and F3 will get you to your viewing window. Generally, most of the time, -10 to 10 is going to do what we need. My TI is already there, my Casio is not. Casio is really easy to change. When the viewing window is up, do you see where it says STD here? Stands for standard. That's button F3. On the TI, if I want to just change it to standard, Zoom 6 will change it to standard. On the Casio, once I've changed the equation, exit out of it and click draw. Does your graph look like mine? It looks closer to mine, but it's got something weird about it that I've got to address. I'm going to borrow yours for a second if you don't mind. Yes, I just straight up stole it. Okay, if you have a TI-83 calculator, does it look like this? Okay, then you're fine. We're going to talk about why the TI-83 and the TI-84 look different. Is there anyone that has a look that doesn't look like either that or that? You put X times 1 instead of X times 1. Okay, I'm back to the question. Does everyone's graph look like one of these two? Yes. Okay, so here's the thing. The TI-83s have an advantageous disadvantage. And I know, right? They mean opposite things too. So, the TI-83s, the technology in them is a tiny bit older, causing the issue of it struggles to jump very, very quickly from the bottom to the top of the calculator when it needs to, and vice versa. My calculator here, this U shape that you can see better on my TI-84, this U shape up here goes from top to bottom really quickly because of the asymptote. Because this one's going up to infinity, this one's going down to negative infinity in a matter of teeny minuscule change in X. So, TI-83 struggles with that. So what it ends up doing is it ends up accidentally connecting these. But here's the thing. The only place it's going to accidentally connect them is at the asymptotes. Which means the TI-83 has the slight advantage of the issues with its technology as it graphed the asymptote for you. That's what it did. Is it graphed that asymptote. Now, here's the bad thing about that with the TI-83s. TI-84, I can very clearly see it goes all the way down, right? Is that as clear on the TI-83? Some people can see this and they're like, yep, I can tell exactly what it's doing. Some people can't. Here is where trace is your friend. Not the person trace. The button trace. Right here on the TI. Right here on the Casio, which by the way, when you're in the graphing menu on the calculator, let me try that again. When you are looking at the graph on the Casio, your F1 through F6 buttons will do this without having to click second first. They'll just do whatever's there. So F1 will be trace on the Casio. But the nice thing about trace is if you're not 100% sure what this graph is doing here because you've got a TI-83 that blocks it, you can click trace. Hey, this says I'm hitting the point 0, 0 on this graph. Cool. But then I can use my right arrow and I can kind of see as X is getting smaller, Y is getting smaller until all of a sudden it bounces up to the top graph. So you can kind of use trace to help you out there. Okay. Once you have what the graph looks like, I want to see what the graph looks like on here. And here's how specific I want it to be. Graph part over here seems to do this thing, and then that thing. Beautiful, love it. The graph part that's on this side of the asymptote appears to do this. Ta-da. It's gorgeous, I know. I'm not looking for more specific than that on these graphs. I'm looking for the asymptotes to be correctly placed. I'm looking for the holes to be correctly placed. We do those things first. We're not quite done yet. We get a few examples, but that's the general rule of what we're doing. That's the general idea. Now, I always make my first example obnoxiously large for some reason, so I'm going to switch pieces of paper. You don't necessarily have to if you've got plenty of space. I write so much the first time. I always do. What's the first thing I told you to look for? If it simplifies, because if it does simplify, what happens on the graph? You get a hole in the graph. Okay, so I try to simplify. In order to simplify, I must factor. 2x plus 1, does that factor? So I put it in parentheses, reminding myself that it's still a binomial. Does x squared plus 5x factor? Yes. GCF is? Leaves me with x plus 5. Does it factor further? Does anything simplify out? No. There's no holes. Do I have to write that down? No, but that is what we're checking for. 2. Next thing we look for is vertical asymptotes. To find the vertical asymptotes, you set the denominator, specifically the part that doesn't cancel out, equal to 0. Now, I can go back to the original denominator if I want, but guess what? If I want to solve a quadratic equal to 0, the easiest way to do it when you've already factored it is, do I factor it? You can jump directly to the factored form equals 0. How do I solve that once it's factored? No. Can't divide by x because you don't know if x is 0, and you can't divide by zeros. Just split up the factors. X equals 0. X plus 5 equals 0. That one's already solved for x. This one's gives me x equals -5. I have 2 vertical asymptotes on this graph. And if there are 2 vertical asymptotes, that means there's how many parts of the graph? 3. One to the left, one to the right, and one between. Next, I check for horizontal asymptotes. I look at the degrees. What's the degree of the top? 1. What's the degree of the bottom? 2. It's easier to check back at the original for the degree. Would you agree that 1 is less than 0, or is less than 2? Which means? Y equals 0 is my horizontal asymptote. Okay. X equals 0. That's right here. Is a vertical asymptote. X equals -5. 1, 2, 3, 4, 5. Is a vertical asymptote, making sure I've got room both left and right of both asymptotes. I do. Y equals 0. Asymptote. Last thing you do is you graph it. Use your calculator to graph it. When you type it into your calculator, I highly recommend you type the original in, because this one is harder to type in. Type in the original, making sure any place there is pluses or minuses, before you put it into a fraction, you're putting it in parentheses. Can you see 3 distinct parts of the graph? One, 2, 3. This one is doing this. Remember, you don't go through the asymptotes. You don't go through those vertical asymptotes, so that's kind of what's pulling it there. This one's doing this thing. And this one's doing this thing. You didn't put parentheses on the number. Yes, when there's pluses or minuses, it needs parentheses. That works. That'll do it. It's just because it's struggling to get there. It actually does go down and up all the way. It's just the calculator struggling. You can kind of tell the tiniest little bit that it goes down, and if you can't, trace. And go to that part of the graph. Up and down, equations, left and right will go along.
No, I just cleared it.
Wait, but
The other option is to zoom on the part that you're not sure about. Zoom in, and then it'll ask where you want to zoom in. I'm trying to tell you, you just keep going to zoom in. We go to zoom in once, just once, and then it'll ask where you want to zoom in. So those little crosshairs popping up there, those are asking where you want to zoom in on. You want to zoom in around here, so then
Oh, I forgot to find it.
if you want to go back, you go back to zoom, and then standard is 6. If you are unable to see kind of what the graph is doing, you're going to zoom in. Now, when you zoom in, first off, on the TI, you click zoom, and then 2 is zoom in. On the Casio, zoom is F2. And then F3 is zoom in. On both calculators, it pulls up a little crosshair. That little crosshair is asking, where do you want to zoom in on? In our case, like you can use the arrows to move that around, but in our case, we want to kind of zoom in around the origin. So I go around it, and I click enter, and it'll zoom in, and it'll show you a little bit closer what the graph is doing. I didn't type my equation into this one. This one's the different equation. That's why it looks different. But it'll look like that. When you're done with that, on the TI, zoom, 6 will go back to zoom standard, and Casio, viewing window, and F3 will go back to standard. Again, that's a different equation. Now, before we are done with notes today, I'm just going to point out one thing. Asymptotes are lines that your graph touches but never goes through. Anyone see an issue here?
The middle line goes through the y-asymptote.
This goes through the asymptote. It's because of how horizontal asymptotes are actually defined. Horizontal asymptotes have a slightly different definition to them. Horizontal asymptotes technically only occur at the extremes of the graph. So at the far left and the far right. The horizontal asymptote does not affect the middle of the graph. Vertical asymptotes do, because of those are coming from things being undefined, which you can't change. So don't be shocked if your graphs go through the middle of a horizontal asymptote. At the edges, they will not. Okay. I have a worksheet for y'all today. You will notice that we did not talk about oblique asymptotes anymore today, and we didn't come across one that had a hole in it today.